Thank you, Andrew. So I'm going to talk about a couple of key topics from the identity ecosystem as it pertains to FIDO. So it's geared towards FIDO as an open authentication standard and how that's playing around with some of the other open identity standards as well. But before I kind of jump in, who is familiar with FIDO? Who is not familiar with FIDO? Okay, so I'm not really going to focus the whole topic on those that are not too familiar with FIDO, as both an alliance as well as the specs. Mike is going to talk a little bit about it in kind of the version 2 perspective. So if you're not familiar with the version 1, I encourage you to find us after the talks and we can talk to you about it, or the other sessions that you can catch up on. So I wanted to focus a little bit on the FIDO U2F ecosystem as it pertains to some new projects that we're doing in the ecosystem of how do we bind strong authentication together with ID proofing, and how a model could work for really an open toolkit that could work with ID proofing and authentication. So the FIDO U2F journey started about 3 years ago. So the specs has been out, the FIDO 1 specs has been out for more than 3 years now. The first service was Google with their clients, which is the Chrome browsers, and then that expanded. These are just some of the relying parties that have made support for it, and the others as well, and other browsers as well as we mature. Now, one of the key principles was about trying to get an authenticator to work with different services with this privacy preserving, and that's a key principle, which is privacy preserving with the ability for you to make sure that you can control your secrets. Now, the first iteration of what we deemed to be combination of how we looked at services as it pertains to ID proofing and FIDO was when gov.uk launched the entire platform for enabling you to register an external authenticator. Now, so today, those of you in the UK, anyone? So a couple of you. So the IDP is that we have is, I think it was DigiIdentity, and so if you go through that IDP, you can actually register a FIDO device to actually do your government services. So this is what we've seen. That was more than almost 2 years ago. Now, what we wanted to do really is to provide a different vehicle, a different platform for how we can solve this. Now, why we talked about this is essentially what we've seen is strong authentication and ID proofing just hasn't really matched together. And why we have not seen this? A lot of the services that we have didn't really need to know who you are in some sense. A lot of social network sites and other services that may not need. And so that typically decoupled the ID proofing perspective to the strong authentication. And typically when you want ID proofing, you do want to really make sure that you can reach some higher level of assurance. And as most of you know today, it's really about trust on first use, right? So you sign up for a service, you can kind of be anonymous, and then you get strong authentication as your account creation. That poses some challenges as you deal with services that actually need to know who you are. A lot of services that are regulated, obviously the banking community, healthcare community, but also a lot of government services. But short of every single relying party knows everything about you, we wanted to think of a slightly different model whereby maybe there were some collective signals where you could share these to know that you were strongly ID proofed and without giving your privacy up for every single service that you sign up for. And we really want to get away from, there was a lot of talk this morning as well that Ying Laser talked about KBA and KBV. And so is there ways to get away from that? Like, is there ways that we can build an ecosystem without forcing the user to remember, what was the transaction that you built on, and, all these names and questions that just seems quite ridiculous over time, right? So every service has its own set of KBA. You can imagine that is a horrible scaling issue that we have. So we work with the folks at NIST. They used to be called themselves NSTIC, but now they have recharted as the TIG, Trusted Identities Group. Now it's important that we take a step back on why we're trying to do this, and obviously NIST is driving a lot of these things through the various programs. But if you look carefully, what it reads here is individuals and organizations utilize secure, efficient, easy to use, interoperable identity solutions to access online systems in a manner that promotes confidence, privacy, choice, and innovation. That's why you're here. So you're here because we are dealing with open standards. We're dealing with an identity ecosystem that can help build the building blocks for whatever use cases that you have. So a little bit of the project. The project is with the NIST folks. We work with a number of various IDPs to, as the scope of the project is a grant that Yubico was awarded to help the school districts. And the school districts mainly focused on, obviously, students, parents, teachers, and the whole gamut. And the reason why we actually focus on this particular ecosystem is that they actually need strong ID proofing with authentication, but you don't always need to have every single school know everything about you from both the parents or the teacher perspective. And so we felt that this was a pretty good model. And we wanted to obviously, naturally, there are a couple of talks already on FIDO extending to the federated ecosystem. So this continues on. We want to leverage strong authentication with federation. That's the goal that I think all of us are building towards, strong authentication with good federated ecosystems. But then we also wanted to think of a model whereby we can actually provide the capabilities to share some of these attributes fairly securely and privately, right, as best as we can. And the other thing that we wanted to do as well with this project was there a model where we could actually issue out a device in a more scalable way after you ID proof the user? So today it's feasible to think that you could ID proof and then give some type of software authenticator, which is possible, but could we do better? Get a high level of authenticated assurance than software? What would that model be? So the general building blocks is that we ID proof the individual, and then we actually bind that credential with the authenticator. And then we ship the authenticators out to the individual based on where they've registered with the ID. So for example, in the driver's license perspective or state ID perspective, you would be shipping it to the address where you registered your address with the body, which is like DMV or something like that. So a little bit more about this concept, which is important to understand is, so we thought about a case where you could decouple these things, but if you actually bound these things together, which is ID proof and then provide the authenticator, then the authenticator that you actually issue first time has strongly bound you, which means that you get strong authentication on first use. Why is this important? Because today, it's pretty common that you created your account, and then later on, you may have to prove something or not, and then you get some ability to register, say, a second factor or other factors. And then you get strong authentication at that point in the future after account creation, which poses some questions about, is this the right user that you just provided strong authentication to? So in this model, we wanted to really address that, which is the first time you use to authenticate, you've already been strongly ID proofed, and therefore, if you wanted to add a subsequent authenticator or strong authentication, you need to rely on the first strong signal, which is not a revolutionary idea, but it's not widely practiced in the industry. And I think that's what we need to gear towards. Once you strongly ID proof and provide strong authentication to the user, you really need to keep the assurance level up, and not every time you default back to a weaker sense of assurance level, which is kind of the current state. So would there be such a model? That's what we want to explore. So most of our work actually has been on the ID proofing portion of this design. So we designed IPV Core. IPV Core stands for ID proofing verification, the engine itself. And then there are a couple components around it, and I'll quickly kind of walk you through that. So the dashboard is where you actually start the enrollment process. The IDP is where you actually initiate the actual user bindings. And then there are other pieces, which is the mobile app on the lower left, which is where you actually going to use your mobile app to scan your driver's license or whatever state-owned ID or passport or whatever that may be. And then the proofing engine itself, which is what is the technology you want to go to do with your remote scanning of your of the app. Now the IPV Core in this case is your OP, in our design the OpenID provider. The dashboard is really your RP in this case. So what we wanted to do is that when you do a registration ID proofing enrollment process, you initiate the flow. And the flow essentially says to the IPV Core, go authenticate the user. In this case, it would go work with the app and talk with the third-party engine and then be able to return your tokens to the RP. And then what really happens at the end is that the user actually gets the physical authenticator together with an activation code. And only at that point when you receive the physical device, you will type in some activation code that you complete actually the whole authentication flow, which is it gives the reason for the RP to release the access tokens to get back the proof, which is actually the key handles in the U2F namespace with the public keys. So what we built is a modular components on how to do the ID proofing engine with the OpenID Connect flow. We built components so that you can use various third parties as the proofing engine. You can use various types of authenticators if you wanted to for the authenticator perspective. You can use various IDPs to do these type of flows. And obviously, you consume it from the service perspective. Various services can work with the IDPs to get really the authentication flow. One of the key things is that there could be two OpenID flows here. You can think of it from the ID proofing perspective, which you actually get your U2F key handles back and attributes, user object attributes, but also the flow where you actually say you're the SP, where you actually want to authenticate with the user. So that's the right side, which is many schools can talk to maybe a central school district authority to say that they've got so really from the school perspective, they said they want to know, is this user valid? Has it been ID proofed? And maybe I want to get guarantees that it's ID proofed, and I may want the address, for example. So the RPs in this case don't need to worry about, first of all, doing the ID proofing flow. They don't need to get user data if they are not privy to those data. And really it streamlines the process for, especially within certain ecosystems, it streamlines every service talking to the IDP saying, you know what, I vouch for this user has been ID proofed, he has an authenticator to prove it, use the authenticator that I've issued to the user, and you can do your flow, your authentication flow, so that he can get access to whatever services they want for the individual. So that's the way we think about the engine and how all the components work. It is a bit complicated, but we did it this way so that you could really dissect things apart. You can plug and play different modules to really enhance the flows if you wanted to. So going on to just the app is fairly straightforward right now. There's a risk score for whether your image is captured in a certain threshold. So you can make some decisions. Do you trust this? In this case, we were using state-owned and DMV-based ID proofing, but you could imagine other technologies that could be in place here to verify whatever ID that you trust in the ecosystem. And then from the authentication flow, we actually provided a couple options. We provided in this case, an SP-initiated flow, and we've implemented both with a SAML connector as well as a OpenID plugin. So you can kind of choose. It doesn't matter. And why can you do that? Because when you have the authenticator with you, you can create your own federated flows, right? SP initiated flows. So, but what we wanted to make sure that we did was that after you've actually said, from an SP perspective, you've got the signals to say, okay, this user's really been ID proof, and there were some attributes related to this user, we could purge everything, not relevant for the user once you've done the flow. And that was one of the important considerations. We should try to purge as much as we can, given that we want to try to keep as much privacy-preserving attributes as possible. So the goal was to, most of the flows that we built actually deleted a lot of the what we call transient ID and transient user information, which is only needed during the ID proofing state and can be completely removed once you've verified and you ID'd the user. Then those can just be said, I've done it, and you don't need to know how, but I've done it, and then continue the flow. So I'm going to provide some of what the outcomes are. So we've really built kind of what we want to provide as a toolkit. We want to provide an identity toolkit part of the grant, which is provide the building blocks for any service or integrators to build upon what we know. We obviously provide the FIDO shims for both SAML-based as well as OpenID Connect. But we also wanted to allow the ecosystem to build kind of the ID proofing engine part and have innovate additional folks kind of build upon that as well. So that was our goal. So to wrap up here was just a few things that we learned. Data is important, as we all heard. Data is really the next target for all businesses, and protecting it is not easy. Any ecosystems, identity systems that we built, it's important to keep in mind that that's the first set of requirements in terms of privacy preserving and limiting data as much as possible. Based on a number of, obviously, NIST guidance, getting higher identity assurance is not easy with remote proofing. And I think there's work to be done in both policy as well as technology to get higher assurance level with really remote capabilities. Because the default right now is that you can't reach the highest level of identity assurance without in-proofing, which I think is in a state that we need to do better over time. And obviously, there's trust all over with various third parties that you use to do either the engine, the actual proofing itself, or whether you have to work with other IDPs or the various combinations you can think about. Obviously, there are, Mike will talk a little bit more about the ecosystem itself, and we as the ecosystem grows, I think the complexities in getting these type of deployments done will be much easier with platform support. So I'm sure that you'll hear more from the next speaker. But really, I think the last point kind of sums it up. We sit very comfortably in rooms like this, planning systems at scale, but sometimes we forget to take care of the people that are not privileged to have some access to devices, or as well as user flows. So please make sure that you do take into account the special needs requirements, not just from schools, but there are a wider community of people that do need special needs. So don't assume that authenticators, devices that you're comfortable with is accessible to everyone. So when you build these type of systems, we learned firsthand. Day 2, I think, was there's a whole bunch of special needs students, and they couldn't do the typical flow that you would expect. So keep those in mind. I think these are useful lessons that industry needs to be aware of. Real life is sometimes a bit different from planning the specs. So with that, any questions?
So I have a microphone here, and I'll bring it to you.
Sure.
So two-part, did you have fallout from scanning the driver's licenses? So did you track errors? And the second part is exactly how did you get the address to mail the key? Was it from the driver's license or some other way?
Yeah. So the question was there, what was the issues with the scanning technology? That was one. The second question is how do you get the address? So we work with one partner today, but from the ground perspective, we can work with pretty much any technology. So I think the technology, how good it is to scan the driver's license or whatever, those are independent. I think you can decide which vendor you want to choose. From our perspective, of course, there are some issues that we've got to work through with the vendor that we choose, but we plan to work with more than one. So I hopefully that addresses the ecosystem of various technologies. The second, where do we get the address? The address is through the DMV. So the technology used is to make sure that you verify the actual issued federal or state ID. In this case, is obviously the DMV case is a state, and we are going to get the address from the DMV database. So obviously, again, if the flow, so the situation where you cannot verify the user with an actual remote proofing technology, then the fallback is you have to come in person with additional documents, just like we do today. So I think that's area that obviously we can improve, but the more that we can try to do remote proofing at getting a high level of identity assurance, I think it's the better for adoption in general for strong authentication and ID-proofed accounts. Yes?
I got the mic working.
I'm curious if you can talk about what, if any, issues you found with using a mobile device, like with the optical capture and with the white light analysis versus UV or IR for actually looking for like IDs, capturing them correctly or dealing with different capture conditions like shadows, reflections, light, or if you've had trouble spotting certain kinds of issues with the IDs based on that.
So you're talking about capturing biometrics as a part of the ID proof process?
No, nothing to do with biometrics, just when you look at a license, there's certain things that, like you can't really see microprint with a cell phone camera. Because
Yes.
Or when you convert to a lossy format, like iOS and Android have different formats, so if you're gonna like forensically look at it, there's certain things you can't see just because in the compression, you lose certain levels
Correct.
of detail. So I'm just curious if like what you found with dealing with just kind of capturing with the cell phone sensor, sort of what the good and the bad you've kind of found there.
Yeah, so what we found is specific to one vendor, and there are at least about 4 vendors in this space that does various forms of phone capture things. I'm not going to talk about the technology because it's really about a building block. But sure, I mean, if you all know, if you hold up your driver's license and you have black light and you can see some things that you can't, I mean, all these things we all know, it's in the ecosystem. I think what we're trying to do is to say that the people that are working on these technologies need to be aware of this. And so the people that build these apps with good or bad cameras have to take this into consideration. I think they're doing better. I don't think we're in a state where they all have good solutions, to be honest. I think everybody's upping their game because this is what we need to have. So if we really want to solve the remote proofing, you're right. We actually need to get this capture thing right. So I'm not going to talk about the ones that we chose, but again, the grant the project hasn't ended yet. So our goal is to onboard additional technologies to see which one is better and provide a report at the end of our project and let you guys decide.
Over here. Hey, so just to understand the concept of building block and identity proofing. So there's 3 layers. One is you scan the ID. 2, you then validate the data with the DMV that it's a real ID and a real address.
Yes.
And then 3rd is you actually have secure postal service delivery to the house. So even if the first 2 somehow somebody was playing a game, at the end of the day, you're still delivering a credential to a house that's actually validated by a DMV as being a real address. So it's those 3 things together that all are part of the identity proofing chain of trust.
Yes.
Okay.
Thank you.
Thank you.
Thank you for clarifying for me.
There's still a number of states where your driver's license is not acceptable by the TSA, and they're going to stop you from flying and all that. Do you
Sure.
accept those IDs from those states?
So we've worked with right now the current state of the project is we work with really 2 states right now, not
Okay.
all states.
Okay.
Again, using the driver's license is an example of a model which you trust the model for providing the ID proof. So the model, if you didn't trust that, maybe you wanted to trust the US Postal Service or Passport. I mean, there are options that you can have. I mean, when we talk about the engine design, you notice that we didn't put out names there specifically on like what we use. We want the ecosystem to know that if you build a building block like this with the delivery mechanism as my good friend Jeremy has talked about, it provides you a venue for building similar capabilities for what is relevant for your use case, right? So third-party ID proofing engine could be whatever apps or products that you trust over time. The app is what's delivered. The core could be part of your IDP, not part of your IDP. So this is what we want to build.
Okay, thank you.
More questions?
Last question, I think.
I have a question about the IDP data stored. Can it be on-premise or it needs to be a cloud service?
So it can be anything you want, to be honest. So we built a combination. We built on-prem. We also have some other earlier prototypes with on the cloud. I think it really, the model is up to you, right? So where do you, just like IDPs can be on-prem and can be in the cloud, right? I mean, you can use a Microsoft on-prem AD, that's your IDP. You can be in the cloud as an IDP. So I think you can decide. The goal is that these are the pieces we feel it's important to build the model right. We will probably tweak some of these things as well to be more efficient in the way that we can improve the flow. But we feel these are the basic building blocks to get started. What we're saying is that we're going to keep the ID proofing verification core separate from the IDP. That's really the basis of this design, so that you can build an entire ecosystem with the OpenID Connect flows separate from the IDP. Now, the IDP just happens to be part of it, yeah, but you could actually think of a model where this IPV core can actually service more than one IDP. So that's how we are thinking about it. So thank you for your time. Appreciate it.
Okay, thank you, Jerrod.
So wait, before any of you go, I need your help with something very important. Our good friend John Fontana couldn't be here because he crashed his bike. And so I want to do something for him, which others did for me at one point, which is we're going to send him a little video postcard with Brian Campbell's help. So we're going to do one practice run saying, "We miss you, John, get better." And then we'll do it for real. So 1, 2, 3, "We miss you, John, get better." Okay, that was for practice. Next time, louder. "We miss you, John, get better." Thank you. So I'm Mike Jones at Microsoft. I work on digital identity standards. And I'm here to talk with you about some of the progress that the industry is making about being able to authenticate, to log in without the use of passwords, or using a strong authentication factor in addition to passwords. So this is what my one complex slide, which I credit Brian Campbell for giving me the courage to do this. This lays out the landscape. You have a human being, a website, and this new thing called an authenticator, which Jerrod also talked about a little bit. So what happens? The user goes to the website. Well, we're all pretty familiar with that. And the user chooses to log in. Well, we're familiar with that. But there's a twist. Rather than logging in by typing a username and password, here, the user's choosing to log in with a key, a public-private key pair that's securely held. And that's the whole twist on the what. We'll do status in a little bit, but first I want you to understand the what. So after the user says, yeah, let's log in with a key, the website has some way of contacting this authenticator device that holds a key. And the key isn't just used without permission. The end user makes some kind of user gesture to authorize the use of the key for that site. That gesture could be touching something, a biometric, typing a PIN. There's a whole bunch of choices, and we'll get into that. But the main thing to know is the user gave permission to use the key. The authenticator signs a response using the closely held private key, sends it back to the site. The site checks the signature on the thing that was signed. If the signature came from the authenticator, it knows we're good. On that basis, I can log the end user in. What didn't happen? There was no password. There was nothing exposed in any of the protocol legs or in any of the user interfaces that could be stolen. And that's the thing which we're getting to as an industry very soon. And I'll talk about how that's going. So what is an authenticator? An authenticator is an abstraction. It might be a piece of hardware. It might be secure software in an operating system environment that securely holds a private key with a corresponding public key. And the authenticator can use those private keys to sign authentication statements. Furthermore, it only uses those keys when the end user gives permission to use them. What kinds of places might an authenticator store a key? Well, there's a bunch of examples, and this isn't an exhaustive set. It could be a TPM on your laptop. It could be a secure element on your mobile phone. It could be secure hardware on a connected device. It could be held in an encrypted blob to be decrypted by the device using a key that only it has. And it's important that this isn't an exhaustive device. This is an area where the industry will and is innovating in terms of the kind of authenticators that are being built and made available to people. Finally, how might the person give permission to use the authenticator? They could use a biometric, fingerprint, retina scan, what have you. He could use a PIN or a touch gesture. And again, that's not an exhaustive list either. Now, in my title, I talk about strong authentication. What's strong about using an authenticator versus other things that you might use? Well, it's actually pretty easy. Authenticators don't expose secrets that are bearer tokens. They don't expose a password. They don't even use them. So there's nothing to be stolen or guessed that's ever out there in the protocol flow. Instead, they keep a private key private, usually in a way that it can't even be exported. And so that key is used for proof of possession, for those of you who know that term, that you do have that device and the device attested that you did want to log in. Finally, the thing that makes it strong also is it doesn't just fire off at random. You can't automated attack to it. It's only used when the end user does something. So you might have malware that tries to get it to sign something, but unless the person says, yeah, I want to do a signature for this purpose, no signature is produced. So how are we making this possible? There's two sets of interrelated standards. Because of the foibles of the way the industry works, they're in two different standards bodies. The web part of this is in the World Wide Web Consortium. So there's a set of JavaScript APIs and functionality that enables you to use these sign-in methods that are stronger than passwords. Again, using these authenticators with securely held private keys that use the private key only with permission, which is given to the authenticator with a user gesture, such as a biometric or a PIN. And so there's a spec that I'll give you the status of in a minute that's underway in public processes in the W3C. Secondly, there's a FIDO2 CTAP, Client to Authenticator Protocol spec, which is used by web authentication implementations to communicate with remote authenticators. So for instance, if I have an authenticator on my mobile phone, if I have an authenticator that's connected via Bluetooth LE or NFC or even USB, there has to be a little protocol dance to say, please sign this thing, get a user gesture, and please get a signature back. And so that's the second part of this. So those will work together. Now, a good question many of you may have been asking, well, is this for the first factor authentication or second factor? And some of you probably already carry U2F devices, which do second factor. Some of you may be carrying telephones with UAF implementations, which do first factor. Part of the reason that the FIDO Alliance did this set of FIDO2 specifications is exactly to bring those two worlds together so that you can use one protocol and, to the extent that it makes sense, one user experience for both use cases. So when it's first factor, the user can be logged in directly using the authenticator. Now that does require, and you want it to require, that the authenticator do something to verify who you actually are. For instance, taking your fingerprint, doing a retina scan, what have you. Even just typing a PIN that you know is sufficient proof in some context that you're Brian Campbell and you're not Andrew trying to impersonate Brian Campbell. Where in the second factor use case, it's assumed that the first factor already identifies the person. In that case, all you need from the second factor is proof of possession of the key. So not only do you know or have the first factor, but you're demonstrating possession of the second factor, in which case you may only need to do a gesture where you touch something that says, please sign it, which Andrew or Brian could touch it and the system can't tell the difference, but it's okay because you have a first factor. Now, I've seen real demos at the Cloud Identity Summit go terribly wrong, and I am not that brave. So you're going to get pseudo demos as screenshots, and I'll show you two of them. One is an example first factor user experience. In this case, using Windows Hello to log into the Win 10 Surface 4 down on the ground there, using a Microsoft-developed protocol that predates web authentication and FIDO2, but that we knew that FIDO2 was coming, and in fact, Microsoft donated that protocol to the FIDO Alliance for it to use as a starting point if it wanted to. Windows 10 implements the authenticator by storing the key in a TPM, and the particular user gesture used to authorize the use of the key, in this case, is facial recognition. So here we go. Here, if the video is any good, which it's not really, you can see that there's a red light at the top, and there's some other illumination at the top of the screen where there's a multi-spectrum camera, including infrared, looking at me, trying to determine not only that I look like me in the visible light spectrum, but that I appear to be alive, which you can determine to some extent via infrared, rather than it just being a cold picture of me. And so it's doing facial recognition. In the next phase, the message has changed. The camera's off. It's saying, hello, welcome. So it believes that I am me. And I happened to take one more shot as Windows was being clever and fading the login screen out to the desktop where I was logged in. And so that all happens typically within a second or two. It's very easy. It's actually quicker than typing the PIN if the lighting is good. So that's demo number one, first factor login. And the FIDO and WebAuthn protocols will be able to do the same kinds of things. The second captured demo is a second factor use case. In this case, using a Yubico device made by Yubico as a second factor to log into a Google account that I have. And it needn't have been a Google account. It could have been my GitHub account. It could be my Facebook account. There's a number of major parties that have adopted this. And like my previous demo, this isn't actually using the new protocols that I'm talking about, just as a disclaimer. This is using an older protocol called U2F, developed by the FIDO Alliance, that is tailored to this second factor use case. The authenticator is attached via a USB port plugged into my laptop, and the user gesture is me touching a capacitive touch sensor, which I'll show you a picture of in a minute. And remember, the capacitive touch sensor is not user-specific. Andrew could impersonate Brian if Brian had already given his first factor. So this looks pretty familiar. That's the first factor login at a Google account. Many of you have done that. Actually, that's the second screen. The first screen asks for my user ID. This screen's asking for my password. And lo and behold, there's a second factor screen where it's saying, please plug in or attach a second factor device. And it has a picture of this particular one in the user experience. So I plug in or have already plugged in this case, a device that looks like that, where the stuff at the bottom is USB contact pins. And the little thing on the upper right sticks out of the USB slot just a little bit, enough that you can see it and touch it. And the capacitive touch sensor realizes, oh, something approximating a human being touched this. I will generate a signature. So where are we on making this happen? This is really a progress report, if anything else. A bunch of us are working really hard, and some of you in this room are part of that set, in the W3C, the World Wide Web Consortium, on the browser side of it, on the web authentication spec. There's a public working draft there. This is the 5th public working draft. And several browsers, including Edge, plan to implement to this, and I won't make commitments for the other browsers, but this is a cooperative effort among many of the browser vendors, not just a few of us. The other spec, the FIDO2 CTAP protocol, the client to authenticator protocol, is progressing in parallel with this. And while in different standards organizations, the core set of participants are largely the same, and the two are joined at the hip in the sense that WebAuthn implementations will call CTAP implementations in order to be able to talk to these magic authenticator devices, which you may have on your phone, which you may have as a new device, which you may have on your laptop pretty soon now. So what's coming? During the next few months, there's going to be browsers implementing the WebAuthn protocol and a version of CTAP. That means that those of you who are developers can start writing experimental applications using that new browser functionality and talking to real authenticator prototypes speaking the FIDO2 protocols. There's going to be interop testing of implementations. In fact, while I say that future tense, there's already a bunch of players, some of them in this room, that are doing quasi-public, pairwise or 3 or 4 or 6 player kind of interops. And I'll step back for a moment. I write standards for a living. One of the things that I think is the most important in getting a standard right is you iterate. You do a round of interop. You ask the developers, did this work for you? Was this ambiguous? Is it missing something? Is this too hard? You get the feedback from what actually happened when you developed it. Then you feed that back into the spec. You iterate. And in fact, with the CTAP flow, there were some great folks from Yubico and others who determined, we had a version of the protocol that would appear to hang to the user during key generation. Well, an RSA key generation on a slow platform can take 20, 30 seconds. So that's not good. You actually don't want the protocol to go synchronous on you there. You want to have it return saying, working. More data coming later. We wouldn't have gotten that right if people hadn't built early implementations. And so the user experience here actually feeds into how the protocol works on the wire. Everything has to work seamlessly end to end, and all that is happening. What are we trying to do? We're trying to make strong, easy authentication commonplace on the web and indeed on your devices. So I always try to end a presentation with giving people information on where they can participate, where they can learn more, or ways to engage. And I know I'll put this presentation up on my blog, which there's a link to there, and I suspect you'll also be able to get it from the Cloud Identity Summit. I'm probably under time, which is fine. I have a simple message that we're doing this, it's happening, it's working, and I invite you all to engage. It's time.
So we have around 10 minutes for Q&A.
Hey, Mike, first of all, thank you for your work on this.
And what's your name? I'm going to ask people who they are.
Adam Lewis, Motorola Solutions.
Thank you.
Thank you, because this is, I think for the first time, we're going to have a viable path away from the password. My question is, understanding the relationship, though, between web authentication and CTAP. As I understand it, we will not be able to actually use web authentication until CTAP completes, because CTAP is 1/2 of the full link.
That's a great question, and it shows that I didn't decouple the architecture sufficiently as I described it. There are classes of authenticators that you will need CTAP to talk to. So something that's NFC paired with your laptop, something where one of your devices is talking to another of your devices, maybe a mobile phone, maybe over Bluetooth LE. And some of the ones that are USB attached, such as the Yubico device that I showed you a picture of, that one you would need a form of CTAP to talk to. That being said, the web authentication spec is intentionally written such that it does not require the use of CTAP to talk to authenticators. It is one of the ways to do it. It's expected that on many of the end user platforms, and I know for Windows this is true, there's going to be a built-in authenticator, the same one that I just showed you with Windows Hello, that the browser will know about and can talk to just by calling Windows System Services. And these will be public services. Chrome could call these, Firefox could call these, Safari could call these. So it's definitely going to be the case that even if you don't have CTAP, but you will have them at the same time, I firmly believe. But even if CTAP lagged, we'll be able to ship a version of Windows. Google will be able to ship a version of Android and Chrome. Other platform vendors may choose to ship WebAuthn that doesn't need CTAP. But again, I believe they're going to largely simultaneously ship just based on the parallel progress that both specifications are making. But great question.
Why don't you point to someone?
Thank you for the presentation. Do you also need to know my name too? All right, this is Raymond. Raymond Shi from Kaiser. So I have two questions. First question is about the second example, as a Google login. I assume that the key the user sent to Google is coming from the computer that the browser runs. Is that true?
That the key is coming from what?
From the Windows system.
In the second example,
Right, so back
the
to...
key is coming from that device, or the signature is being made on
Right.
that piece of hardware, and there's a protocol called U2F where there's a request for signature sent over the USB channel. The signature is performed using a key that's securely held by the device.
Right.
And the signature is returned over the U2F protocol. In this case, through Windows. It could be through Mac OS X. It could be through anything that's capable of talking to that
Okay.
device.
So, all right, my second question is what are the ways to deliver the private key and certificate to different systems?
I didn't catch all of that. You talked about certificates?
Yeah, what are the ways to deliver those keys, the private and public key certificate to different devices?
There's no certificates here. There's only bare keys.
How does the PKI fit into this?
There's no PKI. You are trusting that this key is securely held. You may be looking at sort of in the master class level, there may be something called an attestation, which is a signature made by the device over the attributes of the device that's made in a way defined by FIDO and the manufacturer. And when you install the device and you establish the key, you can get an attestation and you can make a trust decision about whether to trust signatures made by that device. But the format of that is going to vary by device. There's a TPM attestation format, which I would have never designed that way off the record, but it is what it is, and it's a standard, and that's one of the attestations. There's an Android safety net attestation, which uses a JSON Web Token, which is simpler to parse. There's some other formats of attestations. So yes, it is possible to reason about the nature of the device making the signature if you want to. Quite frankly, all of these, even if it's a software-held key, are so much better than a password that I am not personally all that hung up, at least for consumer use cases, about whether to check the attestation or whether it matters at all. There's going to be high security use cases, some high security e-commerce, maybe PayPal checks the attestation, maybe the General Services Administration checks the attestation in some cases. It's up to you, but I just want to stop using the passwords and call it good.
Okay, thanks.
Who else?
Hi, Dean Sachs from Amazon. Curious about the relationship of these standards to U2F and UAF, and will these make U2F and UAF obsolete and any investments in those protocols obsolete?
Well, one data point is that the U2F working group has merged into the FIDO 2 working group. The FIDO stuff is in a different IPR world than WebAuthn, where everything happens in public. But suffice to say, there's a lot of people committed to keeping the U2F investments working. And you can tell that publicly if you know where to read in the WebAuthn spec, which is public, because the U2F signature format is one of the recognized signature formats in the W3C web authentication spec. Will the protocol be exactly the same? No, it'll be the client to authenticator protocol, but we can keep the devices working.
I think we have time for one more. Any more questions for Mike? Front here. If it's quick, we could do two.
Yeah, maybe we'll do two if they're quick.
Okay. So we're looking for yes or no questions.
So maybe you can answer this as a yes or no, but this was a lot about the sort of consumer use case, and does it apply to the enterprise use case? Absolutely.
I mean, the first demo I did was an enterprise login to an enterprise Windows account. So that's a yes. Next question.
Actually, we have more time. We have another 5 minutes or so.
Well, Brian has a more complicated topic. I'm willing to donate time.
When I register multiple authenticators, how does web authentication help me, the user, decide which one I want to use?
If you read the spec, you'll find a place where it sort of gathers a list of all the applicable authenticators, and then in parallel requests all of them to open themselves up for user gestures. And whichever one the user gestures gets to sign. The user experiences around that are well outside the realm of what's in the standard, but what's in the standard is being informed by people experimenting with just those kind of user experiences and saying, you know, this is working okay, this is confusing the heck out of people. And with that, I want to thank you for your attention, good questions, and my friend Brian Campbell.